my calculator did that weird thing that yours did.
Yeah, I don't know what's going on. All right, 6.2, transferring, combining random variables. There is absolutely nothing new in this section that we're doing today at all. Nothing new. We're just going back and reviewing things that we already know. So in section 6.1, we looked at several examples of random variables and their probability distributions. Hey, turn around and take that. We also saw that the mean and standard deviation give us important information about a random variable. For instance, for X equals the amount gained on a single $1 bet on red in a game of roulette, we showed that the mean was -5 cents. You can verify that the standard deviation is $1. That is, a player can expect to lose an average of 5 cents per $1 bet if he plays many games. But if he only plays a few games, the actual gain could be much better or worse than this expected value. Would the player be better off playing one game of roulette with a $2 bet on red, or playing 2 games and betting $1 on each time? To find out, we need to compare, and we'll come back to this. We're not going to do it right now, but they do this within this unit. Compare the probability distributions of the random variables. Y equals a gain from a $2 bet, and T equals the total gain from 2 $1 bets. Which random variable, if either, has the higher expected gain, bless you, in the long run, and which one has larger variability? All right, so that's kind of just setting up what we're going to do for this unit, or this little section that we're doing. We're not going to get to this $2 bet and this $1 bet twice. We'll come back to that. The ones that we do are really easy, and like I told you, it's just a review of what we've already learned. So we talked about a couple chapters ago how multiplying and dividing affected your shape, center, and spread, and how it affected adding, subtract, affected your shape, center, and spread. That's what we're going over again today. Okay, so things that you've already learned, we're just reviewing them one more time.
Did you say next semester will be all something that
This is where it starts. This is where it starts repeating itself. Yeah. So this is where like I said, everything we do today, you already know.
Did you say this semester recorded?
I think it's like an acclimation period, if that makes sense. It's you getting used to the course, and then once you get into this chapter and everything starts repeating itself, it like hones itself back in. So you're like, oh, okay. I remember doing this. Now let's really focus on what we're doing. All right, so linear transformations. Again, we've already done this, chapter 2. We studied the effects of transformations on the shape, center, and spread. And then recall what we discovered. So we talked about what happens when we add or subtract. And we did this with the Mrs. Starnes cabin thermometer or whatever. Guys, please stop. You guys remember the cabin? She was wondering if her thermostat was working right or whatever. We changed Fahrenheit to Celsius, and you'll see that again. You'll see that same formula. But that's what we did. Do we multiply the C by the 9/5 and then add the 32, or do we even use the 32? What happens when we multiply and divide? So adding or subtracting a constant, adding the same positive number A to each observation adds a 2 or subtracts A from. Measures of center and location. And remember those measures of center and location that this will affect is mean, median, quartiles, and percentiles. So mean and median are your measures of center, and quartiles and percentiles are your location. Adding does not change the shape. Or measures of spread. And those measures of spread are range, IQR, and the standard deviation. So the only thing adding affects are centers. Okay, so if they ask you to change your standard deviation or your IQR or your range, and they ask you to add, it does not change. Okay, it will not affect it, it'll stay the same. All right, multiplying or dividing each observation by the same positive number B. So instead of having to write all that out, multiply or divide changes measures of center, which I've already defined up there, by a factor of B. So basically you're going to multiply by that B. It also changes measures of spread, already defined up there, by a factor of B. But remember, nothing changes the shape, so it does not change the shape. Not a lot to write on these pages. It looks like a lot of pages today, but it's really not. There's not a lot of writing. And again, it's all review. Very good. I forgot I detached them. All right, so let's start with a simple example of a discrete random variable. Peach Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. The number of passengers X on a randomly selected day has the following probability distribution. So 2 to 6, there's a 15% chance of getting 2. There's a 25% chance of getting 3, 35% chance of getting 4 passengers. Everybody understand that? That's where that's coming from. This is your histogram. Tell me about this histogram. Describe it. Symmetric, unimodal. So that's your shape. Center at 4. You sure? Look at your chart. Yeah, ranges from 2 to 6. Good. So some of that was what you did in your homework last night. And I told you guys, I keep seeing histograms in the homework. I told you you didn't have to do that if you could do it on your calculator. So if you can do that on your calculator, you don't have to draw them for me. But on your, I told you that a couple times. But if you have any, it's okay. If you have any this time, same thing. You don't have to draw them out. But on your test, you do have to sketch them. Make sure you label and sketch. Yeah, if it says describe, if it describes or it says make one, it's probably because it's going to ask you another question about it. We'll work on it. It's all right. All right. I would not put this on. These I would not put in my calculator. Y'all understand what I'm saying? They're really quick to make. Now, the one where we had like 40 numbers, like I'm gonna put those in my calculator. This I'm not. All right, so the figure shows a histogram of the probability distribution using what we learned in section 6.1, the mean of X is. So how do we get the mean from that chart? I taught you two different ways. First way was what?
You multiply 2 by 0.15,
Uh-huh.
and then you add 3 times 0.25, and then you add 4 times 0.35, and 5 times 0.20, and 6 times 0.05.
Perfect. Or you put them in your calculator, one in L1, one in L2, and you do your one bar stats, but make sure that your frequency list is L2. Got it? So that's the only thing you have to change between your one bar stats. So when we did it in chapter 2, or whenever we did this, when we did one bar stats, you don't put anything in frequency when you don't have a second percentage. Okay, so nothing in frequency, but then on this one, you have to put it in the frequency as L2. When we put this in, it gives us 3.75. So that is, Pete expects an average of 3.75 passengers per trip. This right here is an interpret. So if it asks you to interpret the mean, that's an interpret.
On our homework, do you want to see everything worked out like that?
Yes.
Okay.
Like this?
Yep.
No, you can do it your calculator.
Okay.
It's fine.
So I've been writing out like every.
No. Now, y'all, if it's something like this is what's going to happen. If they ask you to show work, yes, write it out. But if it's 20 numbers, please don't spend 20 minutes in your writing it. You know what I'm saying? When you can get it from your calculator. If it's like this and they ask you to show work, which is what it will be, it'll be something smaller. They're not going to ask you to do 40 numbers. They're not going to. So that's why I didn't make you do it when we did the APGAR scores. But like for this one, we wrote it out because it's only a couple of numbers. All right. Same thing with your homework. If it's a ton of numbers, do it in your calculator. If it's a couple and they ask you to show work, go ahead and show it. So if I give it to you on the test, it's going to be more like this, and that's what you're going to have to show work. It will not be the APGAR where you got to do 40 different calculations. I can't justify wasting your time doing that when we can do it just as easy with 5 numbers. Make sense? All right. So then the variance, how do we find the variance? We're going to go ahead and go over that formula again, but remember you can find that in your calculator. How do you do it in your calculator versus by hand? So what's different about your calculator? What does it actually give you? It gives you the standard deviation. So how do I find the variance? I have to square it. So that's okay if you do that as well. So in your calculator, if you want to find the variance, find that standard deviation in one bar stats and go ahead and square it. Otherwise, this is your formula. I don't expect you to use the formula. I don't. It's too long. It's too ridiculous when you get a lot of numbers. So y'all think like me. I want you to be a little bit lazy, but not a lot lazy. Does that make sense? So on this one, you could write it out. On the APGAR scores, I would not want you to do every bit of that. And I didn't do it in the notes. I don't expect you to do something that I wouldn't do for you. Okay. So on this one,
I have a question.
go ahead.
So if you want us to do it in the calculator, like on the like AP exam, how would we show our work if we put it in the calculator?
Okay, so on your AP exam, if they say show work, you're really going to make sure that you write this out. They're not, like I said, they're not going to give you a free response where you have to do 40 scores. Okay, they're not going to do that. They know that you're on a time limit. However, in the multiple choice part, they might give it to you and you just have to find it multiple choice wise. Does that make sense? So I want you to be able to have your calculator so that like if it comes up in multiple choice, you can just throw it in there and move on. But if you have it by hand, you have to know the formula so that you can show your work. And these formulas are on your formula sheet. So we'll talk about those when we look at those as well.
So the exam is basically how to do both.
Yes, yes. But there's not a lot of these. You'll see. Usually it's not find the mean and the standard deviation unless it's in multiple choice. It's more of the state plan do conclude that you're finding it's ridiculous. Correct. So, and we'll go over all that once we get there. Okay. So we would do, your observation minus your mean. So you have to find your mean squared times your percentage. So this is defined. Yeah, we're doing X. Sorry, your variance. And then you add it to the next one, which would be 3 minus 3.75 squared times 0.25. I'm not going to keep going. You guys understand what you're supposed to do. No point in writing it all out. When I do put that in, I get 1.1875. So then how do I find the standard deviation? So take the square root of 1.1875 and you get 1.0897, which is your standard deviation of X. This last paragraph or sentence is an interpret on a randomly selected day. The number of people on a trip typically differs from the mean by about 1.0897 passengers. All right, just to show you the calculator one more time. I keep switching between calculators, so I don't know which ones. Just to show you the calculator one more time, L1 and L2, 2, 3, 4, 5, 6, 0.15, 0.25, 0.35, 0.2, and 0.05. And then we would go to stat, calc, 1 bar stats. But notice how your frequency list is empty. That's where you got to put your L2. So frequency is just like if you just had this. What's the mean number of, mean number of passengers, you just put it in there. Got it? But when they start putting a percentage with it, you have to put that into L2, make that your frequency list, and then calculate, and you'll see your mean is 3.75. If you look, your standard deviation is that 1.0897 that we had to get your variance, square that number. Everybody good? Okay, so don't forget how to do that. All right, next page. The rest of them are pretty much that quick too. So it seems like it'll seem like a lot of pages, but it's not. They're all quick. So then it said he charges $150 per passenger. So we want to figure out his total amount of money that he collects. So $150 per passenger. So this is the formula that you're doing right here. This C equals 150X. And remember, X is from the last time. Okay, so that last one that we just did, we're just changing it a little bit. So then it says, from the probability distribution of X, we can see that the chance of having 2 people or X equals 2 on the trip is 0.15. So in that case, since C is 150X, if we're trying to figure out how much 2 passengers are going to cost, we multiply that together, or how much money he's going to collect, and that would be 300. So instead of 2 in this chart like the last time, 2 people make him collect $300. But the probability stays the same because it's still the same chance that you're going to get 2 people. Okay. So one possible value of C is 300 and its corresponding probability is 0.15. But what if we have 3? So we're moving up in the chart. We're doing 150X. Now we're doing times 3, which gives us 450. So 3 people will collect $450, but there's still a 0.25 chance that 3 people will go on the trip. How would I get the 4 passengers total? 150 times 4, which is 600. I just want you to know where these numbers are coming from. And still a 35% chance. This one would be 150 times 5, which is going to be 750. And it was a 0.20 chance. And then 150 times 6 is 900. And there was a 0.05 chance. All right. So what do you see now? What's your shape? Why? Why didn't it change? And multiplied doesn't affect shape, right? Correct. So our shape is going to be the same throughout this, okay? So what else? The spread is from, okay, but what about your range? Hmm. Okay, so it's a lot bigger. Okay, we'll talk about that. So multiplying, does that affect it? Okay, okay. And then what's the last thing? Center is at, so, okay, so everything we talked about. So shape does not change, but center and spread does, right? When we multiply. All right. So the figure above shows the histogram of the probability distribution. The mean of C is, when we put these numbers in our chart, guys, I'm not going to make you sit here and work it all out. You would do the same thing. You would do 300 times 0.15 plus 450 times 0.25. Y'all got that? Or put it into L1, L2. Gives you 562.50. So $562.50. So to interpret that, on average, Pete will collect a total of $562.50 from the half-day trip. Calculating the variance, we would do 300 minus 562.50 squared times 0.15 plus blah, 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 blah. Or we would find our standard deviation in our calculator and square it. So our variance for C is going to be 26718.75. And to find the standard deviation, we would do the square root of 26718.75 and get 163.46. Again, all those can be found on your calculator. I don't care, that's fine. Okay, we know how to do it by hand. We've already talked about it. All right, so let me throw this out there. Let's see. Let me see if I can do it. Yep. All right, so what was our median on this, we said? This was the very first one where we had the passengers. What was our median? Yeah, I want the median because you can see it. We said it was 4, right? So what would the median on this last one that we did, what would that be? Okay, 4 and 600, remember that. I don't want to do, you can look at the standard deviation, but it's not whole numbers, so that's why it's really going to suck. So we're not going to look at that. We're going to look at your range. What's your range on this one? It was 2 to 6, which is 4. This one is, which is 600. Okay, remember that. 4 and 600. They're both the same, right? Okay. So in the previous example, the random variable C was obtained by multiplying the values of our earlier random variable X by 150. To understand the effect of multiplying by a constant, let's compare the probability distributions of the random variables X and C. We said the shape of the two. We just talked about this. That's why I did it. The shape stayed the same. And it should have, because we learned that it was unaffected. And that's between the two for both of them. All right, so I did medians because it's a little bit easier to look at. I'll show you the centers as well, okay, or the means. So I did the median of X and the median of C. Why should we not use median? I shouldn't use it, but I'm doing it for visual purposes. But nope. Yes, if it's symmetric, we should use what? Mean and standard deviation. Okay, so if it's not symmetric, we want to use median and either the range or the IQR. But on this one, visually, this is going to be easier for you guys to see than using the decimals. Okay, so the median for X we said was 4, and the median for C was 600. If you check that out, the median C is actually 150 times the median x. So 150 times 4 is 600. If we look at the means, so I'm gonna kind of break this a little bit. The mean of x was 3.75. The mean of C was 56250. And if you put those in your calculators, mean of C is the same thing as 150. Sorry, that should be an x. Times the mean of x. You can see this one better because you already did it one time. 4 times 150 gave you 600. So the spread's going to be affected the same way because we said the spread was 4 and 600, right? So it's going to be the same way. So on this one, if you look at the total spread, the spread of C was 163.46. Sorry, the standard deviation. The standard deviation of X was 1.0897. And if you put those together, the standard deviation of C is the same thing as 150 times the standard deviation of X. So they're 150, that factor of 150. All right, so let's summarize what we've learned so far about transforming random variables. The same thing, just going over it one more time. What does multiply and divide affect?
Spread and
Affects measures of center. And I'm not writing everything that they did in the book because we've been over it multiple times. Measures of spread. And remember that center and location. But what does it not do? Good. So have we learned anything new? No. All right. So this one sentence, and then we'll take a break for a second. As with data, if we multiply a random variable by a negative constant b, our common measures of spread are multiplied by the absolute value of b. And you won't really see any of that. You might at some point. We have quite a few more pages. All right. How does multiplying by a constant affect the variance? For Peach Jeeps tours, the variance of the number of passengers on a randomly selected trip. So this is just talking about the variance in general. So we already talked about the mean and the standard deviation. So we're going to talk about the variance, which is 1.1875. The variance of the total amount of money that he collects. So total collected is the variance of C was that 26,718.75. So what that is actually 22,500 times 1.1875. So where did that come from? Where did that 22,500 come from? What do we do?
Is it 150 squared?
No, 150, yes. Hold on. Sorry, I wouldn't listen to what you said. What do we do to find the variance? We square the standard deviation, so we would have to square whatever factor was multiplied by the standard deviation. So in other words, the collection is that 150 squared. Times the variance of x. Multiplying a random variable by a constant b multiplies the variance by b squared. So you do the same thing that you would do anyway. Yeah, I can finish the next one. So we're going back to the same thing, except for this time, it says what happens to the probability distribution of a random variable if we add or subtract a constant. So we're looking at his tours. it cost him $100 to buy permits. So what does that do if he has to buy permits? Subtracts. So it says the amount of profit that he makes, and they say call it V. He has to take that 100 from what he collected. So if he only has 2 passengers on the trip, and none of these numbers are right, I'm just going to let you know I screwed this part up. Then we had to go back to what he collected. So we did 150 times 2, which was 300. But then we have to subtract the 100, which would give us 200. This is the only number that's right. Okay. From the probability distribution of C, the chance that this happens, the chances still say the same. These are not right. Don't look at them. This row is worth nothing. Okay. So then the smallest possible value of V is 200. Its corresponding probability is 0.15. If X equals 3, then from the last one, we said C was 450. 3 times 150 is 450. V is 450 minus 100, which is 350. So this one would be 350. And its corresponding probability was the same as the last one, so 0.25. I think for this one, it does too much work. If we go back to the one that we just did and look at the top charts. So we had 300, 450, 600, 750, 900. All we're doing is subtracting 100 from that. So we're taking, these are C's, subtracting 100. So what's your next one going to be? 500, 650, and 800. 500, 650, 800. And then 0.35, 0.20, and 0.05. Those never change. Look at it again. Shape, center, spread. So your shape is the same. Your center, it's not the same, right? What did it do from the last one? It went down 100, right? Because why? So subtract affects center, right? What about your spread? It is the same as the other one. The other one was 900 to 300 or 309, which is 600. This one's 8 to 2, which is 600. So is spread affected? You guys see it. So that's all it's doing, is making you look at it visually while you're going through this. So the mean of V, I'm not going to make you do the work, is 462.50. So interpret that. On average, Pete will make a profit of 462.50 from the trip. The variance, you know how to do that, is 26718.75. So to find the standard deviation, we take the square root and we get 163.46. I'm gonna try to knock out the back of this page. I got like 3 minutes. It should be fine. And then we'll come back in. It's fairly clear from the previous example that subtracting 100 from the values of this random variable C just shifts the probability distribution to the left by 100. We said that it goes down 100. The transformation decreases the mean by 100, but does not change the standard deviation. It's exactly the same at 163.46, or the shape. The results can be generalized in any random variable. So what does adding do? What does it change? Measures of center and location. And then what does it not do? Does not change shape or measures of spread. All right, I'm gonna go out and come back in. You guys come back.